Hello friends, welcome to my channel. Today I'll discuss about how we can build API in serverless using AWS Lambda and DynamoDB. So in AWS Lambda we can use any programming language. For this walkthrough I'll use Rust programming language. There are some pros and cons. I'll try to explain why I choose Rust and why I'm a little bit passionate about choosing Rust as a programming language in Lambda. So today is not very step-by-step instruction, or I'm not going to write line by line code. I already have that program ready. So I'll walk you through the code and some of the important pieces, and I'll try to explain and give a bigger picture because there are so many components involved, and I'll try to demystify, slowly. But I assume some basic understanding about the web development concept and some basic idea about the Rust, because this is not a beginner level. I would say it is a little bit intermediate level video tutorial series today. And if you see this website www.sketchnotes.co, this is I'm developing, and for that I'm planning to create some kind of server side APIs where I want to interact. So you can access my website using a laptop or desktop computer or a mobile device. So when you type this URL, you'll see this kind of application, and you can have the ability to do some, draw your different diagrams, arrows, and you can write some notes as well. Till this point, it is very simple. I am hosted all the static assets. Static asset I mean like HTML, CSS, JavaScript. This particular page is built using React.js. That is also come into the React.js category. And definitely we can have some images. We can have store into the S3 bucket as well. So today I'm not going to explain it. This is very simple. In case you want to know more about that, you can leave me a comment. So I'll create a different tutorial how I'm deploying, what is my workflow looks like. But once you deploy into S3, there is a Route 53 involved, which is the DNS service, where we can map this custom URL with the S3 bucket. But one limitation of hosting in S3 is that we directly won't get HTTPS URL. We'll get HTTP URL only. If you want to get HTTPS URL, you have to do some more configuration using CloudFront. AWS CloudFront is another service which provides like CDN capabilities. But today we are not going to discuss about that static asset part and those kind of configuration. And also I'm using Next.js. I'm not doing more server-side rendering for that. This kind of static page generator I'm using it so that it can handle like different URL. But it is very, maybe if you are interested to know that part of the puzzle, I'll create another video for that. But today I'll try to discuss this right hand side. My intention is to create some kind of APIs so that these nodes can be saved with this arrows, this text information, and this images, and anything you want to create your nodes. I want to expose some APIs so that we can save into some storage. There are various different options I was thinking about. One is used to some kind of virtual machine or like EC2 instance, or I could have created a MySQL or Postgres database. So that is one traditional route. But for my use case, I decided to go with the serverless architecture. Serverless architecture is pay-as-you-go approach. So you don't need to pay for this 24-hour all the time any money. Only whenever you get a request, at that time only you need to pay money depending upon some calculation. So AWS Lambda is quite popular one. There are various different alternative available from Google Cloud or Azure. But because I am more comfortable with AWS services, so I prefer to using AWS Lambda, and which is also quite popular. And one good thing is that the free limit or free tier is quite liberal. We can get 1 million requests per month. So that is quite huge. And after that also there are some pricing model. So if I want to show you that AWS Lambda pricing. See, 1 million free requests per month. And this is the compute time. And if you see this, there are some memory you can choose. You don't need to choose CPU. Depending upon the memory, RAM memory, you choose like 128 MB, 512 MB. Depending upon that CPU, will automatically choose for you. It will be, let's say, 1 core, 2 core, and so on. And the price model will be this 1 millisecond. This is a bit critical, till how many millisecond your particular one request will be executed. Depending upon that, you have to pay the price. But for 1 million request or some kind of some limit, it is free. But beyond that, depending upon this 1 millisecond price, so you have to, if you use like program like for example, Java and other like Python and Ruby, so this should be to execute one particular request, they usually tend to run a little bit slow. So Rust will be, there are some analysis or there is some performance testing done by some people. You can find in Google articles. So Rust execution time is very fast. So I am also exploring. So I am also getting a very good result. If you see my, I'll come to here again. But just to show you a little bit high level. If you notice here, these are some recent invocation in the Lambda. And if you see, this is very important part. If you see the first request, it took around 200 milliseconds, which is also still very fast. But because of cold start, right? If you use other programming language like JavaScript, Python or Java, so you'll get in a call second in seconds or 700, 800 milliseconds. But the Rust is quite fast, even though that fast cold start. This is a concept of AWS serverless. In any serverless, because we are not paying it for 24 hours, so there is no server is running for at that moment. So whenever the first request come, so it needs to launch that like container, and it needs to download your code and have to execute it and do some initialization. So during that process is known as cold start, and usually it takes some more time. I work in some past, like for example, Java Spring Boot application literally take 27 to 30 second cold start, so which is quite huge. But if you see, this is like only 200 millisecond, which can be ignored. But after that, whatever the request is coming, it is single digit, like 26, 33 millisecond. So I feel like it is quite fast. So that is the one of the reason I decided to go with the Rust and learn myself and experiment with how Rust I can build some API. and create a AWS Lambda, serverless APIs. That is part of AWS Lambda. And for that, right, I am using for storing the data. I could have used relational database, but I decided to go for the NoSQL database and DynamoDB. DynamoDB is a managed service which can scale much better, but it has its own learning curve because the way you model the data, way you retrieve, and it is slightly different. And integrating with that API is very simple because AWS provide your AWS SDKs. So you need to only pass some kind of table names and some query, so you'll get the result. But the idea today, I'm not going to explain about in detail about DynamoDB. I'll create a simple table and we'll try to insert some records, and we'll try to fetch the record from that DynamoDB table. But it is a NoSQL database, and the performance is also very fast. Whatever the millisecond latency you see, it is with that. It is the time taken by this execution of this particular code to get from the DynamoDB table or inside it. So including that time, it took around 20 to 30 millisecond time. So all this component is quite faster. And 2-3 months back, AWS introduced a new concept known as function URL. Prior to that, we can't directly access from a browser or Chrome browser. We can't make API call to Lambda directly. We have to use API gateway. There is another component known as API gateway. So that is must needs to be used. So that may be also put additional cost. But for a bigger application, right, it has some additional features you may want to leverage. For example, throttling, authorization, authentication checking. It has its own some kind of features. But for the starting, I decided not to use that. But for Lambda, I am trying to use the new feature known as function URL, so that I can directly expose the URL and directly call from this browser to here. And these two are important piece of this puzzle, because I want to make some bit of authentication and authorization. So for that purpose, I am using AWS Cognito, because earlier application we used to store this user ID password into our database, right? Then we are creating a form, and whenever user enter like username password, we do the authentication like those credentials are successful or not. Then we provide the access. But nowadays, most of this API driven architecture are heavily used like authentication, auth 2.0. So we are going to use auth 2.0, and for this we are trying to use this login credential provided by Google. So you may have seen across multiple times. Like for login, we can use Facebook login, Google or Twitter or anything we like. So I feel like Google is quite popular. So we can do some setups so that we can use this user pool or authentication by Google. So we are not going to store that credential. So it is quite secure. So we'll redirect to the Google, and then they can use user ID password. Or if it is already logged in there, they can select that I'm fine with that. Then we will get that. Then after that, we can check that authentication is successful or not. If that is true, then we can integrate with this Lambda and DynamoDB. So for that purpose, right, in AWS Cognito, we have to do some configuration, the configuration are federated, Google Federation. And AWS Cognito is our main entry point, where that user thing we can do some, call some API if you need basis, do some configuration. So I'll give this link in the description below. So this is very good link where we can use like AWS Cognito user pool. So in Amazon Cognito, there are two concepts. One is user pool, another one is identity pool. So here we have to create user pool only. It is you to do some create user pool, select some default option, and your user pool will be created. So this is the first step. I'm not going into step by step, but it is a bit easy and straightforward. You can create a user pool in Amazon Cognito. Once you create that, let me go inside that. Then you have to go to Google API console. In Google API console also, you have to register a project and you have to ask for a developer API access, and you have to do some kind of initial setups. So all the links are provided here and you can create a project. So I have created a project like sketchnotes-dev, and this is the portal you'll get if you click on API services. So here, once you create this console, there is a consent form and there is a authentication to client credential. This is the consent screen and this is the credential. Here you can OAuth 2.0 client IDs you can create. So this will, once you create some, you do a create credential and follow the options. There you will get the client ID and secret. So that you need to provide into, user pool, whatever you created. So in the click on the federation. This is a user pool. I'll talk about this settings little bit in a while. But in the identity provider, you can choose like Facebook, Google, or login with Amazon and some other thing. Because we are using Google, so you can see a tick mark there, and once you click that, what are the credential you have created here, we can set it up, and the instruction is given over here. Okay. And these are some Cognito domain. All the instruction is provided. I think there is no problem with following through this thing. So once we configure this Google federated IDP user pool, we can set some properties. Like let me explain you. So once we create like our user pool, once we authenticated, we can see like Google username, email address, and some kind of information. And here, this is one important section. Without Google also, you could use like AWS Cognito to sign in, sign out, and all this functionality. So that is also possible. But because I want to use Google login, because many people do have the Google login, so it makes easier for that new user to onboard. Here I have selected username, allow to sign in using email address. So you could have selected this one also, email address, there is no problem. And whatever the attribute you want to store, you can use, for now I use email, or you can use given name and all this information also, or some additional attribute. One more important thing here, if you see this federation thing, this is a Google attribute, this is a user pool attributes. So once you map that one, once the authentication is successful with the Google, so that email address from that Google authentication will be copied to your user pool access. So you can able to access using this, your Cognito. It is a kind of data store you can think about. So you can access like picture, name, and all any attribute you want. So you can map with that. With this is a AWS Cognito user pool. This is a Google user pool attributes. So once you map, you can able to access and use for any profile page or anything wherever in the application. So once you create a user pool, this is a federation. The step I explained. I'm not going to go in detail step by step. I'm trying to give a little bit high level view so that you can follow this and you can able to do that, And there is a application needs to be created. This is for our sketch notes for the web client. So here you say like I want to use Google as a login mechanism. The callback URL is a bit important. This is where this is a hosted URI. Okay. Once you click, I'll click this one. That this is a URL you will give into the login page or sign in page. You can see like sign in or login with Google, right? So this URL you can copy and give it to there. So once you give it, you click it, it will redirect your page to Google. Then you can provide the username and password. And you can accept the terms and conditions that I am happy to allow this client to access to my Google profile. Once you do that, then this particular Google will redirect that token to this callback URL. And this is for sign out, but this callback URL is very important. Once you get that, you can able to fetch that access token and ID token and use for whatever the purpose you want. So this is where we'll get access token and ID token. But there is this allowed auth flows is very important. For the testing and the development environment, we can use implicit grant. That means in this callback URL itself, this Google can pass this token to you. It is secure only, but compared to authorization code grant, it is not very secure. So for production uses, it is recommended to use authorization code grant. Then what will happen? Whenever Google you log into that, it won't give you that access token directly. It will give authorization code. And again, you have to call to that, the backend API passing this authorization code. And backend API needs to call to Google again by passing this authorization code and some other client ID and secret. At that time, it will return the access token. So it is a little bit more secure, but one more additional API calls. But for your testing purpose, I am going to use this, implicit grant. And this is the scopes. What are the information you want to access? Email, OpenID, and profile. So this is the URL we are going to provide. And directed to continue with Google. So because I am already logged in, it prompted me and it will redirect to this page. Callback, access token, and ID token. This is how it looks like. And both are JWT tokens. If you see, there are two tokens received. One is access token, one is ID token. And if you copy this is you can inspect. This is not very, this is base 64 encoded. So if you put into, there is a very good website, JWT.io. So if you see this access token, this is a header, which algorithm we are using to give that is the important information here. And payload, the Google username and all other information. But one important thing to note here, this is a scope, which is the scope it is providing. What are the username? But the email address and the given name and some other attribute, what is maybe helpful. So that is not, you may not get into this access token. So to get those additional information, we have to use this, ID token. Sorry, let me copy again. This is the ID token. ID token will contain some additional information. See this given name, whichever the attribute will map, so that will come here. So given name is important and this email is important. Okay. So this information we are getting from AWS Cognito after authentication by the Google. So it will map that attribute from Google to your callback, and this routing is happening by the AWS Cognito. So to simplify, first, because we just want to make some, before we want to make some API call to our AWS Lambda, we want to get that access token and ID token. And for our demonstration purpose, we are going to use like, ID token only, because from that we want to retrieve the email and given name. So once we get this token, in the first pass or the first today demonstration, I'm not going to be extra secure, like checking the signature and verify against this Google again or Cognito again. I'm going to bypass that all this thing. But because it is already authentication, I got this JWT token. I will make sure this client pass this JWT token mandatory. So they need to pass it. And I'll try to pass, usually you should pass access token, but because I want to, get this email address and that given name, so instead of access token, I'll try to pass this ID token. And I'll try to decode it here in the AWS Lambda and paste that, email and given name and whatever the additional message we pass, so we'll try to store into DynamoDB. That is what we are going to do today. So if you see here, this is like the URL provided by this, can give notes. This is a URL you will directly access in this Lambda. I'll get into explain about more about AWS Lambda. Before that, this is the function URL. We don't need to go through the API gateway, so we can directly make any call. And I'll explain about like how to develop it and what are the steps needs to be done. So we can use any method. For example, post method I'm using to create nodes. So ideally, this should be, once you develop the front-end component, so this should be called by React. They'll construct this message and try to submit this thing. And in the authorization, passing token, this is the ID token I'm using because I want to retrieve the email and password. But in a real case, you should pass this access token here and ID token is to pass separately. Then you should verify this access token again, the Cognito through Cognito. And then once it is authentication passed, then you should do this, fetch this information from ID token. So there are multiple steps you should do. But just to keep it simple, I'm passing this ID token and try to get this email address and password. I'm not making it very secure, but just trying to get the job done in the first pass. So slowly in the coming videos, I'll try to tighten the security So it would be, simple. And this authorization is the bearer token. So if you see, this is nothing but a header. The key is like authorization. And this bearer is a standard name. We just prefix it added. Wherever we are using JWT token, access token or ID token, we use like bearer, and this is token where we are using. Okay. And this is a payload. This ID we could have generated into the backend as well, but I decided to generate this ID into this, front end only. So this post request should do two things. One thing, if it will create a new node if it is not present, or if it is already present, then it will replace the data. This ID, this is the title, and there is a tags here, and the data. This is a free flow data. Inside that you can put any JSON content. The structure is not tightly defined by any schema. So it is just kind of JSON object we store into database so that we can retrieve. But here we created different fields for title, tags, and data. Okay. So once we click send, maybe because I'm recording it a bit slow for this first time, it took around nearly 2 seconds due to cold start. But if I hit it again, it should be definitely millisecond, 7 to 8 milliseconds, because any other further invocation it would be less. And this I'll show you how to create 201 created and some message we printed. So it going to replace. If you execute multiple times, same data will be created once only, but data will be put again and again. So if you give invalid token, so invalid JWT token message you will get 401 authorization unauthorized. So you must need to pass this bearer token. So if you want to retrieve that value, you have to copy this and you have to pass this in the path. This is a node ID. Here you got the data, tag, title, and user. This is additional information I am returning. So the user from the token, email and given name. Here also it is providing this token is mandatory. If you don't pass this token, then it will throw the error for zero authorized. So now I'll try to show that kind of Rust project where I have implemented all this functionality. And this time it take right. Sometimes it is bit changing. It is not that execution time of Lambda. It may be calling from the internet connectivity, the DNS resolution. So this won't be charged as part of this Lambda execution. This would be slightly vary, but our Lambda execution time would be constant. Let me show you that few execution I've done. See, it is more or less nearly same, 30-40 millisecond, and only whenever it is cold start happened, it is 168, because after 15-20 minutes, the container will be shut down and there won't be anything is running. So AWS will keep your container once it executed for 15 to 20 minutes. During that time, if you execute again and again, so you'll get a better, response time within double digit millisecond response. So now let us discuss about like what are the things needed to create in AWS Rust. how we can create, what are the things we need to do. So I'll try to explain it. I think this creating this Rust project, this video is going to lengthy. So I'll create it in a separate video just to explain about the Rust section again in detail. So we'll start from where we left today. This is the part 1, I explained the overview. Part 2, I'll talk about more about AWS Lambda creation using Rust. So it will be more Rust specific in the next video. Okay. Thanks very much for watching. Have a good day ahead. Bye bye.